Jai Hind everyone, my name is Amrita Bhatnagar. I am CSE department from AKGEC. Today I am going to explain a topic of software engineering. The name is Introduction to Software Testing. These all are the content of the software testing. Firstly, we will understand what is the meaning of software testing and why it is required. And second is the unit testing, integration testing and system testing. So firstly, we should understand why we should test. Although software testing is itself an expensive activity, yet launching of software without testing may lead to costs potentially much higher than that of testing, especially in system where human safety is involved. In the software life cycle, the earlier the error are discovered and removed, the lower is the cost of their removal. So software testing is one of the major phase of the SDLC cycle. When we create a software for a particular customer, then we have to find out all the errors and bugs in our end also. So if we do software testing, then we can find out all the error in the earlier stage. And if we find out the errors in the last stage or after delivering the software to the customer, then it will be very costly to rectify it. Next, who should do the testing? The testing requires the developers to find errors from their software. It is very difficult for software developers to point out errors from own creations. Many organizations have made a distinction between development and testing phase by making different people responsible for each phase. Okay, in the case of software testing, we need a new team for the testing because developer will develop the software, but it is very difficult for the developers to find out the errors from its own creations. That's why we need another team for the software testing. So there is a software testing team which will do software testing. What should we test? Now the question is what code we should test. We should test the program's responses to every possible input. For example, the output should be correct or not. It means we should test all valid and invalid input. So we will give different type of inputs and we will check it out the program is working properly or not, it is given the proper output or not. Now the testing objective. Software testing has different objectives. The major objective of software testing are as follows: finding defects which may get created by the programmers while developing the software. So this is the major objective of the software testing, finding defects to make sure that end results meets the user requirements. Means the software requirement specification have many features in the SRS document. So we should understand that these requirements should be fulfilled. So in the testing phase, we also ensure that these requirements are fulfilling or not, to ensure that satisfies the SRS, that is system requirement specification, to gain the confidence of the customers by the providing them quality product. So if we done software testing properly and find out the errors and bugs from the system properly, then it will gain the confidence of the customer because he will get a quality product from the development team. Software testing process. Now the mainly most widely used software testing process, we have three stages, where first one is the unit testing, second is the integration testing, third is the system testing. So firstly we will understand what is the unit testing and why it is required. Unit testing is the method by which individual units of source code are tested to determine if they are fit for use. A unit is the smallest testable part of an application, like functions, classes, procedures and interfaces. Unit tests are basically written and executed by a software developer to make sure that code meets its design and requirement and behaves as expected. The goal of unit testing is to segregate each part of the program and test that individual parts are working correctly. Okay, so what is the meaning of unit testing? In the unit testing, we will test each and every part of the code. It can be a function, it can be a class, it can be a procedure, any type of, or it can be any program also. So we will thoroughly check or test these all the part of the software. This means that any function or procedure, when a set of inputs are given, then it should return the proper value. It should handle the failures gracefully during the course execution when any invalid input is given. So we will check each and every piece of code, and we will check, give the inputs, and we will check the output. If there is any problem in the some inputs, what it means, this module is not working properly, or this function or this code is not working properly. So we will give different inputs, and it can be valid or invalid inputs also there. Advantage of unit testing. First advantage is issues are found at early stage. Second, unit testing helps in maintaining and changing the code. Since the bugs are found early in the unit testing, and it also helps reducing the cost of bugs free. Unit testing helps in simplify the debugging process, because in the unit testing we check all the piece of code properly. So the cost of the system will be reduced, because we have find out the errors in the early stage. If we can't get errors in the early stage, then it will be more costly to rectify the errors or solve the errors. So these all are the main advantages of unit testing. Now the next is the component testing. It is also known as a module testing. The basic difference between the unit testing and component testing is in unit testing the developers test their piece of code, but in component testing the whole component is tested. There are problems associated with the testing modules in isolation. So module testing means we have a module. When we test a module, then this is known as a module testing. In the unit testing, we test only a piece of code. So when we test a whole module, then it is known as a module testing. So there are many problems in the module testing also, because for the module testing, all the dependent modules should be created. If these dependent modules are not created, then there is a difficult to test a particular module. So that's why we need in the component testing stubs and drivers. Now next is what is integration testing. Integration testing is the phase in the software testing in which individual software modules are combined and tested as a group. So because now we have tested piece of code, now we have tested the modules, overall modules, and now we will integrate the our modules, and then again we test the modules. When we integrate the modules, then there is a possibility of different type of errors or bugs also there. So we will integrate the modules, and we will get the we will check the output, fine, or test the output. It occurs after unit testing and before system testing. Integration testing takes as its input modules that have been unit tested, groups them in larger aggregates, applies tests defined in an integration test plan to those aggregates, and deliver as its output and integrated system ready for the system testing. So in the integrated testing, we will integrate the different module and give the inputs to this integrated modules and check the outputs. Is it working properly or not? Now you can see here, this is the example of unit testing. In this case, we have some different piece of code which will be tested by the tester teams individually. So these all are the different piece of code which is tested by the software testing team. Now next is the integration, where we will integrate these modules. So you can see here, these modules are integrated, and then again check, then these two modules are integrated, and then again check, these three modules are integrated, and then again check. This is known as the integration testing. When we integrate all the modules, then we will have a system testing. Integration testing strategy. Then we have different integration testing strategy. The entire system is viewed as a collection of subsystems. The integration testing strategy determines the order in which the subsystems are selected for testing and integration. So these all are the integration testing strategies. First one is the Big Bang integration, or which is also known as a non-incremental. Second is the incremental integration. Third is top-down integration. Fourth is the bottom-up integration, and next is the sandwich testing. So these all are the different testing strategies. Fine. Now the Big Bang integration. All the components of the system are integrated and tested as a single unit. Instead of integrated component by component and testing, this approach waits it all the components arrive and one round of the testing, integration testing is done. It reduces testing effort. Okay. So, in this Big Bang testing, what happens in this integration technique, we will integrate all the modules at a time. We will wait all the modules. We will not integrate the modules which have created and then we will integrate it. But we will wait for the all the modules and then we will integrate all the modules in a one go. For example, you can see here are these all are the different modules A, B, C, D, E, F, G, where we have these all modules. So, when we get develop all the modules, then we will start to test all the modules. So, we will see here when we get all the modules, then because we have tested A, tested B, tested C, already these modules are tested in the unit or component testing, and then we will have already created this modules, then we test all the modules simultaneously A, B, C, D and E, F. So, we will not start our testing if we get the A, B, C and we do not have D or E. We have to start our testing when we will complete or we will create all the modules which are required A, B, C, D, E, F, G. So, all the modules, when we have all the modules, then we can start our Big Bang approach. Next, again this is the example for the Big Bang approach. So, these all our modules are created for the system, then the Big Bang integration testing can be start. Now, advantages and disadvantages of Big Bang testing. The only advantage is that for the all small system, this will be ideal integration testing technique. The disadvantages is that you would have to wait for all the modules to be integrated and there will be quite a lot of delay. Errors are identified at the very late stage. So, advantage is that it is used for the small system where we have less modules, and we can use this Big Bang strategy and we can wait all the modules. But when we have a large system where we have multiple modules, then there is very difficult to wait for the all modules and then start the integration testing. And what are the disadvantages of this testing is because we have to wait all the modules, so it will have quite a lot of delay, fine, and error are find out at the late stages. So, these all are the main advantage and disadvantages of our Big Bang integration testing. Next is the incremental testing. Incremental testing approach means to first combine only two components together and test them, remove the error if they are there, otherwise combine another component. So, we will start with, in this case, we will start with two components, we will integrate these two components and we will test this component. If we have already removed this error from this integrated module, then we will again add another module. And when again we will test this whole module, and if we remove all the errors from this module, then we will add another module. So, in this way, in the incremental integration testing will perform. Top-down testing strategy. Test the top-down or the controlling subsystem first. Then combine all the subsystems that are covered by the tested subsystem. Okay, in this case, we will start from the top modules and then we will go to the next module. For example, you can see here we have A is a top module, then we have B, C, D on the same level, and then we have E, F, G on the same level. So, we will start from the layer 1. Layer 1 is only test A. So, we will test A firstly because this is the top module. Next layer we have A, B. Now, we have A, B, C, D because we have already A we have taken. So, we will include this A in this layer also. So, we will test A, B, C, D, integrate these modules and we will check these modules. In the next module, we have E, F and G. Then we will test all the module A, B, C, D, E, F, G. So in this way we can check all the layer 1, layer 2 and 3. Fine. So, in this strategy we will start from the top modules. Okay. Then we will come to the next module. interfaces can be tested in the various. Now we have two various schemes to check the check the integration testing in top down integration. We can have breadth first integration. So in this case you can see here in the breadth phase integration we will check like this BCD, EFG or A. So we can have these all components we will integrate like this in the breadth first integration testing. And next is the depth first. In the depth first integration techniques we will have ABE, ABF. So we can see here ABE, ABF. So we are familiar with these two strategies. What are the breadth first integration? We will start from the breadth first integration in the horizontally, and the depth first integration we will vertically we will find out the modules to integrate. So this is the scheme for top down integration. Next is the advantage and disadvantage. The advantage is that if the prototype is released or shown, then most of the main functionality will already be working. And disadvantage is basic functionality is tested at the end of the cycle. So the advantage of the top down is that main functionality can be tested firstly because we start from the top level, but the some functionality will be checked in the last cycle of the testing. Bottom up strategy. In this bottom up strategy we will start from the lower layer only. So this is the just opposite or just reverse strategy of the bottom top. Here we will start from the bottom and we will go up to the up. For example, we will start from the bottom and we will go to up. Then the next subsystem are next tested, that called the previously tested subsystem. This is repeatedly until all the subsystem included. Drivers are needed. So we can say one example. You can see here again we have same example A, B, C, D, E, F and G. Now we will start from the bottom level. So in the bottom level we have E and F. So we will combine this B, E, F and B in the first test integration testing. Then here we have G only. Then we will combine G and D and G and we will test this. And the next one is a C. So we will combine, and firstly we will take this and this component, and then we completely test all the modules. So we will start from the bottom and go to the up layer. Advantage of and disadvantage. The advantage is that with this method we would be able to maintain code more easily. Then there is a more clear structure of how to do things. Disadvantage is that when the releasing a prototype cannot see a working prototype until nearly all the program has been completed, because in this case we will check the basic functionality. We will not check a main functionality of the prototype. So there will be a problem in the case when we are releasing a prototype, because the main functionality of the prototype cannot be checked or tested properly. Now next is the sandwich or bidirectional testing, which is a combination of top-down strategy and bottom-up strategy. The system is viewed as having three layers. First one is a target layer in the middle. Second is a layer above the target, and a layer below the target. So we will have a target layer. We will combine these two strategy, top down, and in the top down we will start from the top, and in the bottom up we will start from the bottom. So we will start from the top and bottom both. Then it is known as a sandwich strategy, because we are starting from the both sides. Fine. And there is a target layer also. So we will start from the first layer. We will start from the top, and next layer is to start from the below, and the middle layer will be the target layer. How we will perform this? You can see here, this is the same example. We have A, B, C, D, E, F, G. So in the case of, we will start from the E, F, G, H, and we will start from the A also. So okay, so we can see here we will start with A. Either here we will start E, F and G also, and at last we will test all the layers. So we will start from the top and we will start from the bottom also here. You can see this in the example. You can see in this example, this is the sandwich integration, where we have, this is the target layer. So we will start from the bottom as well as we will start from the top. So the target of this strategy is the main target layer. If the complete target layer, then all the system will be tested. Now next is the system testing. System testing is most often the final test to verify that the system to be delivered meets the specification and its purpose. It tests both functional and non-functional aspects of the product. It is started once unit testing, component testing and integration testing are completed. System testing is carried out by specialist testers or independent testers. Right. So now we have integrated all the modules of our system. Now there is a requirement of the overall testing, which is known as a system testing. When we have all the system developed, and now we have to thorough testing of the whole system and find out the errors and bugs, so that our software's quality can improve. It is performed on the basis of written test cases according to information collected from SRS and detailed design document. So in this case, we will write some test cases and then we will see what are the main functionality we written in the document, and then we will test our system. It ensures that the product is ready for moving to the user's acceptance test level. Okay, and so we will have to see that the user requirement should be fulfilled and user should accept the our product, so that we have to test our system properly. This is the last chance of the test team to find any remaining product defects before the product is handed over to the customer. So in the system testing, we will check all the software properly and find out the errors properly. Now, the system testing can be of three types. First one is your alpha testing, second one is the beta testing, and third one is the acceptance testing. Alpha testing is a testing technique which is done by the developer side. When the whole system will be developed, then some members of the developer team or testing team will do this alpha testing here. And the beta testing is the testing where we have some customer level persons or customer friendly customer. You can say we have some friendly customers or few family friendly customers, and this beta testing will be done by these few friendly customers. Now acceptance testing is performed by the customer only and in the environment of the customer. When we deliver all the software to the customer, then the customer will check the product in their environment also and find out the errors and everything, find out the check the every functionalities are working properly or not, which is given in the SRS, and then the customer will give the acceptance to the product. So this acceptance testing will be done at the customer side when the product is already delivered to the customer. Fine. So this is the main types of alpha testing. This is the alpha testing is being done by on the developer environment, but by the developer tester, and the beta testing is done by on the environment of the developer only, but we have some friendly customers also who will test this system, and acceptance testing is done on the environment of the users or customers and by the customer only. Fine. So these all are the main testing techniques which we have discussed. Thank you.